The purpose of this lab is to observe Newton's second law of motion using an object moving at constant velocity. To do this, we will observe a shuffleboard disk on a shuffleboard. We will import this video into a piece of software called Tracker. Using this software, we will take measurements about the object and use these measurements and the video to create a graph and data points of the object's motion over time. We will then use Newton's second law, which is final velocity equals initial velocity plus net force divided by mass times change in time, to create a model for this same motion in Python. Using this code in Python, we will generate a graph and data points, which we will then compare it to the observed data. The graph and data will show that while the model closely predicts the observed data at some parts, it is unable to accurately predict the observed data at all parts because of the quality materials and because of friction acting on the shuffleboard disk. Here is video of the shuffleboard disk sliding on the shuffleboard. I will show the video again at a slower speed. Here is the video placed into the Tracker software. The disk has been placed at the origin to zero all measurements, and the disk will move along the x-axis. The coordinate axes have been oriented so the disk will be moving in the positive x direction. Using Tracker, the length of the video has been shortened so that only the frames where the disk is seen in motion will be used. Using the measurement tool, we can determine the length of the disk. Knowing the length of the disk, we can determine how far the disk moves. This data is then collected and graphed. Here is a close-up of the position data. Here is an enlarged view of the graph. Now we are going to examine the Python code used to model this experiment. Using the data points shown in the top right, the start time, initial position, initial velocity, and the time of the last observation were recorded. In addition, the mass was found separately. All these measurements are needed to use Newton's second law in the form shown on the screen. In this circle is the code used to implement Newton's second law. In this code, the net force is set equal to a vector of zeros. Because velocity is constant, net force must be zero. The final velocity is set equal to the initial velocity plus the net force divided by the mass of the ball times the change in time. And the position is set equal to the position times the velocity times the change in time. When the code is run, a graph is generated that shows the position of the model movement over time. Here is a graph of the movement of the disk. This graph shows both the model data and the observed data and was made in Microsoft Excel. The model data, which is shown in the straight line, overpredicts the observed data for the second half of the time. Before a tenth of a second, the model data closely predicts the observed data. This phenomenon is observed for a few reasons. The surface on which the disk was slid was covered with wax, however the wax was not distributed evenly. The wax makes it easier for the disk to slide by reducing friction. However, patches that had less wax would have had more friction than patches that had more wax. In addition, this shuffleboard disk has been used before, and the bottom of it was worn in several places and scratched. The scratched areas are less smooth than the more polished areas and would have more resistance to the surface than the polished areas. It is also worth noting that we only had 7 data points for our observed data versus 19 points for our analysis model. More points for our observed data would have given us a larger view of the accuracy of our model. Overall, to make this experiment better, a newer disk From our analysis, we can conclude that the model can closely predict some parts of the graph, but it will not be able to predict all parts of the observed data. In the experiment shown, the model predicted the beginning of the observed data better than the latter parts of the observed data.